question, so 9, 8. So basically what I did was let's see, for -2 to 3 and fx equals 3x squared minus 6x, determine the domain and range of f at x. So we have our quadratic formula, and they told us the domain, so I wrote the domain right away. In order for me to write the range, I had to do a sketch. Oh, okay. And so basically what I did was I can't really sketch from the standard form. All it tells me is that the y-intercept is 0. And so, yeah, I completed the square, and then I found the formula. Okay. And then I used the vertex 1, -3, and that's what I plotted right away. And then I used a step pattern, which was 3. So um, so during the last session, I talked about the step pattern, and the step pattern is coming from this. So this is from the side notes, okay? So the step pattern is 1, 3, 5, and the reason that is because when you have y equals x squared, these are the coordinates that you have for the quadratic. So 0, 0, 1, 1, 2, 4, 3, 5. And so what the step pattern is saying is that, okay, so when I move over, when I have a shift of 1, I'm going up 1. When I go right 1, I have a shift of 3. And when I go right 1, I have a shift of 5. And that helps me draw the parabola every time when, let's say, the a value is 1. Because right here, we have an a value of 1, right? So that's a step pattern for a general quadratic function, right? And so let's go down to our case. Where we were at. Okay, so over here. So basically what I did was because the a value is 3, I no longer have an a value of 1, but an a value of 3. And so instead of having 1, 3, 5 as my step pattern, I have 3, 9, 15. Okay, and so what I did was I drew the vertex, and then I went right 1, and then I went up 3 times according to my a value. Okay, that's like the first step of the first step. So I would go 3, 9, and 15. I didn't go ahead and draw all of the parabola, but like the main idea, right? So that's why I'm going up by 3. And so so I went right 1, up 3, and then I went left 1 from the vertex and up 3 to draw my 3 coordinates. Once I did that, I drew my I didn't really know at first what my graph was going to look like. I kind of tweaked it as I went by. So initially, I had a graph that looked something like this. And then what I'm doing in my green writing is that it's showing that I'm moving 1 over. So that's 1 over. And so if on the left side I'm moving 2 over, that means I have a relatively like higher optimal value, like a higher y value for that. And so that's what I'm showing you in the green, the 1 and the 2. Anyways, so my sketch was like this initially, and then I try to find my values. So I'm doing my writing in green to find the range. So that's what I'm focusing on. So according to my little drawing, it showed me that, okay, so I know my lowest value is going to be -3 because of the vertex. And so I started off by writing that. So I initially wrote that, and I needed to find my highest y value because that's what my range is. It's like, where does my y's exist? Well, from the lowest point to the highest point. And so I should really extend this range because I think I initially thought the range was around that long, but it was really a bit longer over there. And so what I did was I plugged in the -2 value into the x, and then I found that the value was 24. And just in case, and depending on how accurately you did the sketch, you might have not known that at 3, the y value was less than that. Because, like, to be honest, when I was drawing it, I thought, with a really rough sketch, I thought it was this part that was going to tell me the range. And so, oops. And so Okay. And so then I just did a little check on this side at f at -2 and then f at 3. So I noticed that the highest value was 24. And because according to my sketch, my highest point is going to be here and it's going to be here, that is my range. And so I went ahead and I wrote my range for that. And keep in mind that this part over here, we're both open. Is it supposed to be open? Let me just check. Well, for the 24, that makes sense. And for my -3, I don't think I checked the textbook for this. For the -3, it might be including. Yeah, it is including. I didn't check carefully enough. It should be including. And do you understand why it's including? So the reason it's including is because like it includes that vertex. So I have to actually change that. Where did the -2 come from? So -2 came from the domain, the original domain that they gave us. Okay, so they told us that my graph. So if we look at when we think about the parabola, parabolas in general, they don't have restrictions, right? But they told us that you're gonna have a quadratic from -2 to 3. And so that's where the -2 came from. So in terms of question 9A, does that make sense? Were there any questions within 9A? Mhm. Oh, and then you said about how you got x-intercepts. Oh, okay. The x-intercepts, it's because it's just how the step pattern ended up landing on. For this example, it landed perfectly. Because when I was drawing the drawing, I had it at 1 comma -3. And when you move over right once and up 3 exactly, I land at 0 comma, oh, sorry, 2 comma 0. And so in terms of this question, that's how I got the x-intercepts. Meaning if I was to redraw it, 1, 2, 3, 1, 2, 3, 1, 2, 3. So it was 1 and then -3. So I knew my A value was 3. So my step pattern is 3, 9, and 15. So I went, okay, I'm going to go over once and then up 3. Well, that's going to land right there. And then left once, up 1, that's going to land right here. And so that's how I got my x-intercepts. And then I went, okay, so it's up till -2. So I went, okay, somewhere there, let's say. And then it's up till 3. So it's gonna be like somewhere here. So that was my initial like very messy sketch. And sketch are supposed to be a bit messy.